Okay, here was the problem that seemed to be put. You gotta, especially, you gotta be on this here. You're gonna be gone. This is the one that people had trouble with. This problem. I mean, yeah, there were some other ones there were some minor issues with, but this is the one that far and away caused the most problems. If it weren't for this problem, the people that did the test, the average would have been really pretty high on that test. So let's take a quick look at maybe just a couple like this, a square root and a cube root. So we're supposed to write this function graphed, right? Now I'm giving you all the information you need there. All we need for this thing is we got to know the identity of the special point. For a square root, it's the starting point. For a cube root, it's the point of symmetry. It's the middle point, right? Okay, so for this square root here then, what are the coordinates of that point?
-5.
5, -3. Okay, so 5, -3 is HK, right? The other thing I need is I need to know how aggressive is this function? How much is it rising or falling as I move to the right? Yeah, so we look over, if we go over 1, that's A. How much is it rising? Well, it's rising by 2, isn't it? It's positive 2. So A is 2, H is 5, K is -3, and all we do is just plug it into a standard square root function then, right? So we just want to plug that into f of x equals A times, this is square root, right? Because it's only on one side. Everybody agree? Square root of x minus h plus k. So what's this going to look like then? For us, we've got f of x equals 2 times the square root of x minus 5
-3.
plus -3 is just -3. So that's my answer right there.
That's all you type in the calculator?
That's it.
Yeah. I mean,
And you can use that, you can use this fancy editor, right? So what you see is what you get when you use that editor. Remember, the part that people are likely to make a mistake on is you got -3. Is it inside or outside of the radical? Outside. There you go. It's got to be outside the radical. Okay? So there's one. Let's look at another one here real quick. Let's see. How about... Let's pick a cube root one. Yeah, there's one. Okay, let's use that one. This isn't mine. I'm pulling this off a test, off one of your tests. Okay, so let's look at this one. Square root or cube root? Cube root. Shh. Okay, cube root. Now, where's my special point?
right there in the middle.
Right there. So, HK equals what?
2
-4.
-4.
2, -4. And now we got to find A, right? So we're going to go 1 to the right. And in this case, down 2, so that's -2. Right? So what do we get then? We get
-2
f of x equals A times the cube root, right?
X minus
Of x minus 2
-4.
minus 4. Done. That's it. Right? Okay, no big deal. Let's look maybe, what was the other? That was far and away the worst problem. What was second worst? This guy. Okay, this kind of problem was the second worst. let's look at maybe one of these.
Yeah, calculator.
It's non-calculator, so you
Oh.
can't. Non-graphic calculator. Where's Gabe? Gabe, you got it.
Look there. Yeah.
Okay, so real quick, what's that? If it needs your immediate attention, go ahead. Okay, what about this one? What do we do here? How do we solve a radical equation? Yeah, good. We isolate the radical, which is already done, right? The square root is by itself, and then how do I undo a square root? Square both sides, right? So we're going to do this. We've got the square root of, whoops, square root of 3 minus x equals x minus 1. I'm going to square both sides. What am I going to get over here if I square both sides? 3 minus x, right? If I square a square root, it undoes it. And then over here I get x minus 1 squared. Okay? So I've got to now, if I'm going to solve this equation, I have to expand that out, get everything on one side, and just solve the equation. So if I FOIL this out, x minus 1 times x minus 1, or I use the pattern, x squared minus x is minus 2x, right? Plus 1. Right? Okay? So let's get everything over on this side, because we want a positive number of x squareds. So we'll minus 3 and add x. Right? So we end up with x squared minus x minus 2 equals 0. Well, let's go ahead and put the equals 0 over there. How about? Right?
Is that just our answer?
No, we're trying to solve this thing. We got to find the values of x. So how do I? This is old stuff. We can do this in our sleep. How do we solve a quadratic equation? Factor this one, or we could use quadratic formula if we really wanted to. But this factors, does that? Factors into what? X minus and plus, minus 2 plus 1. If we set those equal to 0, then we've got it factored. If we set the factors equal to 0, x minus 2 equals 0 when x is 2. X plus 1 equals 0 when x is negative 1. Are those my answers?
Yes.
Maybe. What do we have to do?
Oh,
Plug them in.
Got to check them. Okay, let's check them. What if we try x equals positive 2? If I put 2 in there, I'm going to get square root of 3 minus 2 equals 2 minus 1. Is that true? I get square root of 1 equals 1. So that works. Okay, let's try the other one. Negative 1. If I put in negative 1, I get square root of 3 minus negative 1 equals negative 1 minus 1. Does the square root of 4 equal negative 2? No, it doesn't. 2 does not equal negative 2, and so x equals negative 1 is out of there. That one doesn't work, right? So then what are our answers if we write these in increasing numerical order? There's only one answer. 2, NA, NA, right? Okay, make sense? Okay, good. All right, graphing calculator. Let's quickly take a look at a graphing calculator question or two. Okay, these ones, I mean, these should be pretty darn easy. I purposely picked all these questions so they're not hard to graph. You don't have to do any wacky, crazy stuff with your screen. You have to just do maybe just a little bit of moving around, but not very much. So let's try one here.
What's come says next week, right?
Yeah.
What day?
Wednesday. For the compass test? I mean, you can always take it at Blue Mountain or something too. It's, yeah. And there's a possibility. See, are you, you're not a senior, are you? No, right, you're a junior, aren't you? Yeah, so when you get back, we can take it too. We'll figure something.
Oh. It's not timed, right?
No,
So we can take like 17 days.
you could.
Yes.
How many poems are on the compass test, Mario?
Oh, what did it do that for? I can't remember. I don't know if it even.
A question a day.
It actually varies. It just depends on.
When's the smart bar? Did the first one pass? Or finish?
There we go. Okay.
Damien's always the first one to finish. He always passes. Whoa. You guys know what's true.
What happened?
Okay, let's look at this guy. So this is all graphing calculator, right? Okay, can I have attention, please? All right, let's look at this. What do we do? All we do with this is we're going to go up to y equals, and we're just going to
Enter.
graph the left side is y1, the right side is y2, and we'll intersect the two. So 2 times the quantity 3x plus 4
The power of 1/3.
yeah, to the power of 1/3. Okay. There's the first guy, and then the other one's just x minus 6. Okay. Let's just go ahead and hit Zoom 6. We don't really know exactly where it's going to be, but we'll start off with Zoom standard. So there's our cube root function,
Really?
and there's our line. Now look at this. Think about the behavior of a cube root function. Wouldn't you agree that this cube root function if I were to keep going with this thing, it's just going to kind of keep on flattening out, whereas this line is going to keep getting further down, right? Up here, it looks like this one's going to kind of keep moving off to the right. So the intersections, how many intersections are there going to be? It's going to be one. Where's it going to be? Bottom left or upper right? Yeah, it's going to be up there somewhere, isn't it? So what do? Just make the window go, instead of going from -10 to +10, let's make that x max 20.
And minimum 0.
And we don't, I mean, we could, but we don't even have to. I want to be quick about it, so I'll just graph it so I can see to the right a little bit further. So I can get that intersection, and there it is. There's my intersection, right? There's only one of them. That's it. So I just go second, calc, intersect, enter, enter, and then I want to get a guess, so I'll just kind of go up fairly close to it. Although in this case, there's only one intersection, so it's probably not even going to matter then. That's probably close enough. Let's hit enter, and it found it. It went right to that intersection, and it's 13.008. They want it to, how many places? I don't know. It tells you on the, what's it say? I can't remember. But all we have to do is just enter that decimal then, rounded however many decimal places Moodle tells you. You know, make sure you read the directions. That's it, right? No big deal. Questions on that? That seems to me like that's absolutely a freebie. Say it again. Right, it says, it says find the greatest real solution. And then I cut the rest off, but then it tells you around it to so many decimal places. If there's only one solution, what's the greatest solution? That one. It's only one of them, right? What would be the least solution? That one. If there's only one of them. The words greatest and least really only make sense in the context of multiple questions. If there's only one, then you just put your solution down. Okay. Make sense? Now, if this thing intersected the curve more than once, then we'd have to pick the one to the right, wouldn't we, for the greatest?
Right.
Right? Okay. All right. Let's try one more of those.
About, is this a good one? Let's see. How about this guy? Is that a good one? Okay, yeah, this is a good one. Let's do this one. Oops.
I think that's good for you. He's a junior.
Okay, so what about this guy? What if we want to solve this? Now, there's a couple ways you could do this easily with a graphing calculator. Right? I just want, and this is, chapter 7. Not much to chapter 7, really, is there? I just want you to know a quick way to do it. Well, we could graph it. That's fine. We can do that. If I just go y equals, just clear this guy out of there, and I could graph the function x to the 8th. And then I want to set that equal to 6,071. Right? And I just want to know when that happens. Okay, so now that's a pretty big number, right? My y is going to have to go pretty high, isn't it? Right? Make sense? So what do I want my window to be? If I want to include that y value, right? Because I want to be able to see that horizontal line.
6,100.
So if I go, what if I went from 0 to 7,000?
Too big.
That's not pretty big.
Right? That's x though. I don't want x, do I? I want x to do that. Yeah.
You want to just take the 8 through that number.
Exactly. That's the other thing I'm saying. We can take the 8 through. So let me.
Or you can just make it happen.
Okay. So I could do this if I want to. I could make y max 7,000, and I could just graph this thing and see what I can see. And there are my intersections, right? That's easy to do. I can just find those intersections. Is it easier to not graph it? Absolutely. How do I solve this thing? Well,
Aim for it.
if x to the 8th equals 6,071, then what's x equal to? What's x? I mean, how do I find x? Eighth root.
6,000.
But what am I forgetting? I gotta have a plus or minus because it's an even root, right? So the far easier way to do this would just be to say 6071 to the power of 1/8 is that. So it's plus or minus that, right?
Yeah.
Okay. Now what if that had been like x to the 9th?
1/9.
Then I do 1/9. Do I need a plus or minus?
No.
No, I don't. Okay. Alright. The other ones there that require our attention.
The heart. She told us.
What about sunshine? Oh, that's Dan.
Okay, how do we do this? How do we do this one? I could square root both sides and add 2, that's fine. Or, it's a graphing calculator test. I could just graph this guy on one side. So y1 is x minus 2 quantity squared, y2 is 14, and find the intersections.
Just say
I
what
mean,
it is.
should I even do it?
No.
I don't think I need
Go
to.
left.
No, let's talk about time. Dimension.
I want to get discussed on exactly.
Believe next Thursday.
Okay, this is an absolute gimme. Look at this one real quick.
Bring it. Why don't you subtract 7?
Okay. If I want to find the value of this radical, I can just put it in like that in my calculator. That's kind of a hard thing to do. The one thing I got to remember here is, how do I write that as a fractional exponent? Right? If I can remember that, this becomes very simple. So the 7th root, whoops, the 7th root of 225 to the 4th equals 225, the base, to what power?
Q.
The 4 7s, right? We know that the 7, being as that's the index of the radical, that has to go on the bottom. And then that's just a normal exponent, right? So we're multiplying 1 7 times 4, which is 4 7s. So this one goes on top, that one goes on the bottom. Put that in my calculator, be done.
Earlier.
Right? Believe me, I did.
You did?
Yes, I did.
So would you.
Yeah, QA.
You've never been thought.
I do have been talk.
Okay, so
Talk about